Hello everyone, in this video we will talk about our college project, where we observe the behavior of grains in test tubes. Grains are a part of our daily life. Good grain separation tools are essential to ensure higher quality grains arriving at our homes. But what happens when they start behaving in ways you didn't expect them to? That is a question that we had to face. Our original plan was to study the Brazil nut effect. However, as we spun several different grains utilizing a vortex mixer, we noticed that the bottom and top grains were spinning in different directions, with the bottom grain spinning counterclockwise and the top grain spinning clockwise. As nobody understood what was going on, we chose to study that instead. For the methodology, we used an 18 mm diameter test tube as a container. We tested the phenomenon with rice, beans, corn, pigeon peas, and mustard grains. For it to be more visible, we painted some grains using nail polish and placed them at the top and bottom of the tube. The grains were spun using a vortex device with 9 different frequency levels, and each level was analyzed with a tracking program. That way, we would be able to obtain the periods of the grains and measure different angular velocities. The effect was well seen within the grains. As the vortex frequency intensified, the grains at the top would begin spinning first, while the bottom would remain compact with little to no movement. Once the frequency was high enough, the top grains would be spinning clockwise, while the grains at the bottom would be spinning counterclockwise. However, once a certain frequency was reached, the angular velocity of the grains would become lower before the entire body began spinning clockwise. The group has named it point of inversion. With these low motion videos, the effect is more obvious. Notice how the grains move counterclockwise at the bottom and clockwise at the top. These graphs represent a visual correlation between angular velocity and frequency levels from 1 to 9. The blue lines represent the angular velocity at the top, while the orange lines represent angular velocity at the bottom. Positive results indicate clockwise motion, and negative results indicate counterclockwise motion. For black beans and corn, the point of inversion happened at frequency level 7 of the vortex mixer, showing longer periods and lower angular velocity before all grains started spinning clockwise on frequency levels 8 and 9. With pigeon peas, it happens a little earlier. The point of inversion happens at frequency level 6 before all grains start spinning in the same direction at level 7. For pigeon peas, the grains are smaller and very round, making them less compact at the bottom. Rice was different though. The grains will remain still up to frequency level 5, where the top grains will begin spinning counterclockwise. In frequency level 6, all rice grains will spin counterclockwise before turning to opposite directions at levels 8 and 9. We believe this has to do with the thin, elongated shape of the rice, which contributes to a more compactified state and increased surface contact. As a result, it causes greater friction. In that sense, while mustard does not have the counterclockwise spinning at first, it also shows greater resistance to switch to full clockwise spinning. The small size and greater quantity of the grains may have contributed to this behavior. Well, why does the effect happen after all? We believe it is a matter of rotation and translation. When there are two round objects, such as the container and a grain, as the test tube is spun in a circular motion, a grain goes through a translation in the same direction of the spinning. Due to the friction between the glass and the grain, its rotation spins opposite to this translation. When grains are compressed at the bottom of the tube, they tend to behave as a single body with a diameter similar to the containers. The lack of space between the grains and the glass makes translation extremely small. Rotation, on the other hand, can be clearly seen as the grains spin counterclockwise as a single body. As for the top, the body of grains becomes less compact and each grain experiences a higher degree of freedom, behaving as multiple bodies. That way, the clockwise translation of each individual grain is visible. Once frequency reaches higher levels, the friction force no longer keeps the bottom grains together as a single body, and all grains start spinning in the same direction. Overall, we noticed that the effective compactification of granular media was the main parameter of the phenomenon, with big influence of grain quantity, shape, and size. The movement of the granular bulk at the bottom is a result of compactification of the grains, causing a movement of a single body rotating counterclockwise inside the tube. Meanwhile, grains at the top move rather freely, being excited to move along the clockwise turn of the tube. We were unable to find similar studies and honestly think this is a funny little experiment that should be analyzed better and deeper. Maybe one day it could be useful for science, who knows?